All right, so let's begin the second video, and we're going to start off with our second example. Determine the theoretical probability. So this is a theoretical, so without any action and only using our mind. Given a bag of 20 marbles, there are 15 red and 5 that are blue. What is the probability of choosing a red marble? So I'm just going to make 15 red. 1, 2, 3, 4, 5. Now I have 3. There's 15 red. And I have 5 that are blue, so I'm going to choose a blue color here. And 5 that are 1, 2, 3, 4, 5. So as you could probably see, right, you can literally see the probability here. But determine the theoretical probability that a bag given of 20 marbles where 15 are red, 5 are blue. What is the theoretical probability of choosing a red marble? And the probability of choosing a red marble is going to be, I take a look, well, how many in my sample space are red? Well, there is 15. How many marbles are there in total in my sample space? There is 20. Some of you guys might have been able to spot out, well, the probability of getting red is going to be 1 for every 4 times as well. You can also do that. You can also say 0.25. That's correct. That's expressed as a decimal, or 25%. So that's theoretical. Notice that I didn't do any action. I just used my brain. So let's move on to example 3. Now, example 3, I needed to do some experiment here, and so I took a good portion of my morning, but rolling a 6-sided die 60 times on your table. So I brought out a 6-sided die, and I've rolled it 60 times on the table. So I'm going to keep track of my results. And my results here, so for instance, it was 6-sided die. I rolled a 1 8 times. I rolled a 2 12 times. I rolled a 3 11 times. A 4 9 times. There. This was my frequency. And frequency just means the number of times. So the relative frequency really says how many times have I rolled a 1. So I rolled a 1 8 out of 60. So I'm going to choose to express that as a decimal and as a fraction. So that's my relative frequency. Now, 2, I definitely rolled a 2 a lot. So it was 0.2. 3 was also pretty good, so that was 11 times out of 60 that I rolled it. Kind of surprising. Take out my calculator, and that's 1.8. Sorry, can't be right. That is 0.183. 4, I rolled that 9 out of 60 times. And that is 0.15. The 5 is 13 out of 60 times. 60, sorry. And that was 0.217. And 6, I rolled 7 out of 60 times. Now, wow, that's very, very little. So this is probability. When I actually roll the dice, for instance, you know this about playing board games, sometimes 2 comes up a lot, way more frequently than a 6. Sometimes it just happens that way. So B, what are your expected results, assuming you rolled the die 60 times? Well, what did I expect? Well, keep in mind, I'm rolling it 60 times, and the probability of rolling a dice is 1 in 6, I'm going to expect to roll 10 of these. Now, that's just the expected amount, right? Because 1 in 6 is equal to 10 out of 60. So I'm going to expect to roll each of these outcomes 10 times. And the probability there is 0.167. And it's going to be the same for all of them. And I guess I shouldn't write that, but hey, I'm almost done. So what happens is that the experiment, and we call this the experimental probability, is different than the theoretical. And generally, we can expect that. Things are left up to chance. But the more and more times we do it, if I tortured you guys and said, roll it 1,000 times, what we would notice is that the probabilities, the experimental, would approach the theoretical. So compare your results. Now, here, things looked okay. Like, compare my results. I would say there are some differences. That's what I would do, right? There are differences. And I'm just going to say there are minor differences. What would happen if the whole class's results were all put together and we calculated the relative frequency? Well, if we get everybody in the class to put their results together, we would expect the relative frequency to approach the probabilities. Really big lesson in probability. All right. So I'm actually going to stop the video there. It seems like a logical place to stop. So that's theoretical versus experimental probabilities, and really important. And stay tuned for